Hello, and thank you for joining this presentation. My name is Hans-Martin Heyn, and I'm from the University of Gothenburg in Sweden and Chalmers University of Technology. And I'm going to present a paper on requirement engineering challenges for AI-intense system development. The paper has been written together with Erik Knauss, Amna Muhammad, Jennifer Lindner, Padmini Subia, Shamir Pradhan, Sagar Tungal, and Olof Eriksson from Vilnius, Sweden. The aim of the paper is to introduce the Vetliot project, or Very Efficient Deep Learning in the Internet of Things, presentation of research challenges that we will be facing in Vetliot in the field of requirement engineering, and we would like to introduce an initial set of research questions that we would also like to discuss later after this presentation. So what is the Vetliot project? As I mentioned, Vetliot stands for Very Efficient Deep Learning in the Internet of Things, and it is a European Union Horizon 2020 project started last year in November. Its mission is to design, develop, and demonstrate next generation of cognitive Internet of Things devices using a heterogeneous distributed architecture, integrated accelerators, leveraging a tool chain based on AI and deep learning, and demonstrating it with a wide range of different use cases. The project is run by 12 partners from industry and academia, distributed in 5 European countries, as you can see here on the map. And as I mentioned before, Vetliot is built around use cases, and we have currently 3 areas of use cases. We have use cases from the industrial Internet of Things, we have use cases from the automotive sector, and we have a use case from smart home sector. In addition, we will have an open call, meaning that after we have developed the Vetliot toolchain and the accelerators, use cases can join and use this toolchain as validation of our concept. The idea is to develop this very efficient deep learning in the Internet of Things toolchain that works with different accelerators on different cognitive IoT platforms, ranging from embedded, which means super small and very power efficient, to small. Those could be, for example, platforms that are integrated in mobile phone base stations, basically on the edge, and medium. Those are typically in the cloud in some data center. And all of these applications need to ensure security, privacy, and trust, robustness, and safety. And all of this, the use cases, the toolchain, the hardware accelerators, the cognitive IoT platform, they are all basically glued together by requirement engineering. And that's why I would like to concentrate today on the requirement engineering aspect of the Vetliot project. And there we have 3 major research objectives. The first one is the context, understanding, determining, and specifying the context of operation for a complex distributed AI system is of key importance to understand how the system will actually in the end behave, and also to define how the system should behave. Then we have data quality. Knowing the context, we need to understand, determining, and specifying quality of data and other data attributes related to the design and operation of these complex distributed AI systems. And then there's an important part are the human factors. Including human factor knowledge in the design of complex AI systems will be of key relevance, because if you cannot create trust between an AI system and a human operator, it is very likely that a human operator will not accept the system and therefore will maybe not use it. An example is if you have a really good emergency braking system in a car, but the human operator doesn't trust it, he might override or switch the system off. And then the system's purpose of saving lives or making driving more safe cannot be fulfilled. So based on the 3 use cases, and I can very briefly mention that the first use case will be handling fault detection in industrial applications, here in the case of a switch gearbox for smart power grids, for example. And the idea is to detect faults so early that you do not run into the danger of having a power cut due to a switching error in one of these switch boxes. The second use case will come from the automotive application, and there it will be the system for automatic emergency braking. And you might think, okay, but all cars that I can buy today, they have automatic emergency braking. Yeah, that's true, but most of those systems are really not that smart. For example, they might detect an object, but they are not going to classify the object if it's safe to drive over the object or if you have to do an emergency braking. And especially when you are driving on a motorway with high speeds, it might actually be quite dangerous to do an emergency braking out of a false reason. If there's a paper box that is empty on the road or piece of styropor, you might not need to do an emergency braking. It might actually be quite dangerous to do so. So artificial intelligence here could help us getting a more safer automatic emergency braking system. Plus, you could also decide where you would like to do this classification of if you need to do an emergency braking or not. It doesn't necessarily have to be locally on the vehicle itself. Maybe if you have some form of smart road infrastructure, you could actually do this decision somewhere on the edge, for example, in a specially designed mobile phone base station next to the motorway that can do this decision for you with much faster calculation power, if you can guarantee the latency for data transmission. And the last use case will come from smart home, and it will be a smart mirror that has facial detection, gesture detection, and natural language processing to assist you in your everyday life. So based on these use cases, I already mentioned 3 problem areas: contextual definition and requirements, data attributes and requirements, and human factors. And I'm kind of sneaking one more problem area in, and that is the problem area of performance definition and monitoring. And you need to answer all these problem areas in order to be able to guarantee a certain system behavior, guarantee system quality attributes such as safety, robustness, or quality in use, and also to give process support and development support, because most likely most of the AI systems will be deployed in some form of continuous deployment, meaning like you will have continuous improvement of your systems, but you need to support this. So I will start now to talk about each of these problem areas and define a set of research questions. And I will start with contextual definitions. The system is normally designed and tested to perform safely only in a priori defined conditions. And in the automotive sector, these operating conditions are known as operational design domains. And contextual definitions are related to assumptions or belief. An example are that you assume certain probability distributions over parameters of a machine learning model that you are going to use. And the research questions that arise from there are: what challenges arise when deriving contextual definition and requirements from use cases? Which practices would be appropriate for deriving contextual definition and requirements? And how to express and document explicit or implicit beliefs based on the derived contextual definition. And the next problem area are data attributes and requirements. An AI will be trained with data representing a context in which the system is expected to operate. So I think I don't have to mention that artificial intelligence and any form of machine learning basically lives on the data that it has available for training a certain behavior into it, and also on the data that it's being presented with during the operation. If this data is not correct, then you will never be able to achieve the desired behavior that you actually want to have from the AI. So data often originates from many different sources with varying degrees of quality, which can be challenging for the ability of ensuring the system's behavior in a given context. And the research questions that arise here: what are relevant challenges for managing data quality requirements when developing large distributed systems based on deep learning? And what constitutes a data quality framework for developing large systems based on distributed deep learning? There I can maybe go also a little bit more into detail, because imagine that you are an OEM and you are producing, or you developed a really cool AI for making driving more safe, and you deploy it, but you know that probably you should also monitor and collect a lot of data from your vehicles while the system is operating, because you know that your context might be over time changing very slowly, and you need to continuously collect data in runtime or you need to collect data out of the field to be able to retrain your model to compensate for this drift in context. And you need to handle this data. You need a framework to be able to manage all this data that you will be collecting, because it could be on hundred thousands of vehicles where you collect data. And the last research question is, to what extent can relevant challenges of managing data quality requirements be mitigated by a data quality framework for developing systems based on deep learning? Let's get to the problem area of monitoring. Continuous monitoring of the system allows for continuous integration and control of the machine learning model. Performance definition and monitoring of machine learning-enabled systems allows to check that the system actually stays within its guaranteed system behavior, and especially also within the assumed context that you hopefully have before derived properly. So the research questions are, what are suitable performance metrics or KPIs for trained machine learning models in a given context? What approaches are possible to compare or compete different trained machine learning models for a given context? And then the last research question is, what faults can actually occur in a machine learning model, and can faults in a machine learning models be classified in different categories? And for this research question, we actually found a really interesting European Union project also. It's called Pre-Crime, and it's being conducted at the University of Switzerland in Lugano. And this research question basically has been answered by the research team of Paolo Tonella. So in a good literature survey, we will be already able to answer this research question. The next problem area are the human factors. And this connects to a project called Shape It, which stands for supporting the interaction of human and automated vehicles, preparing for the environment of tomorrow. And the aim is to focus on how the intended user will actually interact with the AI system in a realistic context. And an AI system can only fulfill its purpose if a human can trust it, which I mentioned quite early in this presentation. So the research questions are, in what way must human factors be considered for understanding and ensuring system behavior for an AI intent system? And in what way must human factors be considered for understanding and ensuring the system quality attributes of an AI intent system? And last, how can human factors knowledge be effectively used in modern system development approaches? Then, after answering all these problem areas, we also need to consider how do we integrate and deploy an AI system actually. And in system development, there's a general trend toward more agile DevOps and continuous deployment with self-organized teams. And our intention, our idea is to facilitate quick decisions for AI intent systems and to prepare for scalability and to move the responsibility for activities related to our problem areas more towards the development teams as much as possible. The research questions are, what are characteristics of suitable requirement information models? What are characteristics of suitable traceability strategies? And what are characteristics of suitable methodological support? And how could a preliminary roadmap for the requirement engineering research in the Vetlio project look like? Well, first we would like to understand what is the current state of practice, and that you can do best with a set of qualitative exploratory studies. And then you can use design science research to iteratively design artifacts that improve or establish this new state of practice. And then we can use the use cases from Vetlio to demonstrate the artifacts in a real-life setting. And the ultimate goal is that we would like to be able to define, okay, this is our expected behavior for the AI system in a clearly defined context, provided with the right training and the right runtime data, monitored to ensure that the expected behavior is actually met in the field, and to continuously maintained and developed in order to, for example, correct for drift in the context that could occur over time. I would really be happy to discuss especially the research questions now with you in the next 5 minutes. Thank you for your attention.
Okay, we are live now. Thank you, Hans Martin, for your talk. You already have some questions in the chat, so I'm going to go ahead and read you the first question. It's from Lionel Briand. He says, to me, the requirements engineering challenge in ML-enabled systems is that the requirements, to some extent, are learned from data and implicitly captured by models, what are the consequences for RE then?
Thank you, Lionel, for this really good question. I think, first of all, you have to look at the entire system, because the ML part or the artificial intelligence component might only be a part of the system. So I think you have to start with looking at the requirements on a higher level for the entire system, and then try to figure out, okay, what are actually the requirements? What requirements do we break down that will end up on the AI model? And then I think you're absolutely right. Most of those are actually learned from the data, because you have to see, okay, what data do we have available for training our AI model? And that kind of depends also, that kind of determines also what kind of requirements we can actually set on the AI model. And then when you have an AI model, it is often, you train it with a certain data set, and this data has certain attributes and certain quality aspects. And you have to check in runtime that these are actually still fulfilled with the data that comes in at runtime. So maybe you might even have to put certain requirements onto a monitoring system that checks that your data attributes and data quality aspects that you had during your training and your testing of your AI model is still fulfilled during runtime. Otherwise, you cannot make any guarantees or any statements on the behavior of the system in runtime.
Okay. Thank you very much. I definitely agree with the monitoring piece. You know that. So a question from Silverio Martinez. Following that reasoning, which RE support can be given for new data, new requirements when evolving, retraining the models?
Maybe I can pick up this monitoring aspect again, because such a monitoring system has the advantage also that it will detect if you are, for example, running out of the context for which you have trained your AI model originally. And that might give you ideas on the requirements that you have to put on new data that you need to collect. The problem often is that you might have a lot of data, but the interesting data is actually these edge cases, or, well, what an AI model does, it basically tries to represent a certain probability distribution function. And what is really interesting for training the model is to capture exactly this data that is on the tails of the probability distribution. Mm-hmm. And if you can put requirements out that you need this kind of data, that would probably be really, really helpful.
Mm-hmm. Okay, I have a question. So when I watched your presentation in preparation for today, it's quite a large scope. I mean, it's a lots of research questions, a large scope. So from an execution perspective, where are you in the project? Are you just proposing it, or have you already started executing it? Like, where are you in the project?
Maybe it has a little bit to do with the fact that I started my postdoc in January this year. So it was really in the first weeks of my postdoc that I wrote this paper. When you start a research project, you have a lot of ideas that you want, where you think like, okay, this is something we could look at. And then you start to break it down to actually some small subcategory of where you really put your focus on. And we actually figured out that these data requirements, data quality attributes, also, if you look at the presentation that we just saw from H&M, I think there's a lot of open questions on how do we handle in a company data properly. He called it like data lakes or something. And being able to actually specify the concrete data that we need for our AI development, I think this could be a really interesting topic. Then what has been discussed earlier too is about monitoring of the behavior of the AI based on the data that we used for training it. I think is one of the key aspects that one has to look into.
Okay, and yes, we only have 30 seconds, so I don't know if you'll be able. Oh, go ahead, Eric.
Yeah, so you asked where we stand with the project. I mean, they have both started. It's two projects basically. In Vetleot, we can focus a lot on the system requirements, and in Shape It, we look a little bit more on the human factors and the user requirement side. And it's really a very comfortable situation to look into both, but it's a really tough scope. So we try to stay really on the breakdown and rely on our strong partners also a lot.
Okay.
I think where we